partial differential equation. Dear students, so we know what is a differential equation. Differential equation means an equation which consists of, in simplest meaning, differential equation is an equation consists of the differential coefficients. So what is a partial differential equation? Partial differential equation, consider the equation is of the form, it is of the sum del z by del x plus del z by del y equals sum x plus y. This is a partial differential equation. So means an equation containing one or more partial derivatives of an unknown function of one or more independent variables is known as a partial differential equation. So this is an example of a partial differential equation. Now, the order of a partial differential equation. What is the order of a differential equation? We know that the order of a differential equation is nothing but the order of the highest order derivative which presents in it. And the order of a partial differential equation is nothing but the order of the highest partial order derivatives which presents in it. And that is independent of the radicals and fractions and so on. Radicals. Okay. Now consider, let p x y z. Let p x y z be any point on a curve. Be a point on a curve, and it is given by the curve which is represented by x equals x of s, y equals y of s, and z equals z of s, where s be the arc length, that's from a fixed point on the curve. Then what are the direction cosines? Now here we seek the direction cosines of the tangent to the curve at this point pxyz. The direction cosines of a tangent, so consider a curve, this is a curve. Then here pxyz be any point on this curve, and the curve is represented by this form x equals x of s, y equals y of s, and z equals z of s. And you can draw a tangent. You can draw a tangent to this curve at the particular point such, so p, at this particular point p. So equation of the direction cosines of this tangent, suppose L be the tangent. You can draw a tangent to this point p, to this curve, then the direction cosines of this L, the point p x y z is given by, it is dx by the triplet dx by ds, dy by ds, and dz by ds. So the triplet, is dx by ds, dy by ds, and dz by ds. So this is the direction cosines of this tangent to this point pxyz on the curve C, which is represented by x equals s, xs, y equals y of s, and z equals z of s. So suppose that the equation of a curve, the equation of the space curve C is given by the intersection of two curves. There is a space curve and whose equation is given by the intersection of two curves. Suppose it is find the direction derivative of the tangent. So the equation of the curve, suppose it be a space curve whose equation is given by the intersection of two space curves. Suppose one is S1, whose equation is f of x, y, z equals 0, and S2, that is g of x, y, z equals 0. So the space curve Z is given by the intersection of these two space curves. Then we want to find out the direction ratio through this L, where L be the intersection of this line. We want to find out the direction ratios of the tangent at the point pxyz to this curve C. And let pi1 be the tangent plane of this S1. So there are two curves. So let y1 be the tangent curve, y1 be the tangent plane to S1, and y2 be the tangent plane to the curve S2. So, and the L be the intersection. L be the tangent to this point of intersection. This is P. This L. So L be the tangent line that is passing through the P. P be the point of intersection. Then what about the equation of y1? Here equation of y1 is this is x minus small x. X minus x into del f by del x plus y minus y into del f by del y plus z minus z into del f by del z equals 0. Similarly, equation of y2. Equation of this tangent plane y2 is, it is x minus x into del g by del x plus y minus y into del g by del y plus z minus z into del g by del z equals 0. So this is equation of the tangent plane. Why? Because this is del g by del f by del x, del f by del y, and del f by del z are the direction cosines. So this equation of y1 and y2 are given. It is x minus x del f by del x plus y minus y del f by del y plus z minus z del f by del z equals 0, and del of y2 that is on G. So what is actually L? L be the intersection. So the L be the intersection of this y1 and y2. Then what is equation of this L? So equation of this L is given by equation of L, this point of intersection. Equation of L is given by x minus x divided by, it is del f by del y into del g by del z. Del f by del y into del g by del z minus del f by del y into del g by del z minus del f by del z into del f by del z into, it is del g by del y equals y minus y by, we know what is the equation of a straight line passing through two of the points whose direction ratios and direction cosines are given. So all of these things are well known. So by using that arguments, the equation of L is x minus x by, that one, equals y minus y by, it is del f by del z into del g by del x. Del f by del z into del g by del x. Del f by del z into del g by del x minus del f by del x into del g by del z. Del f by del x into del g by del z equals z minus z by del f by del x into del g by del y, del f by del x into del g by del y minus del f by del y into del g by del x. So this is the equation of this L, where L be the tangent to this space curves which are passing through the point of intersection of these two, pi1 and pi2, where equation of pi1 and equation of pi2 are given. So the equation of L is obtained from these two. Okay. Now this can be rewritten as, that is this is x minus x by del f by del y del g by del x. So this is nothing but it is del f g by del y z, that is the Jacobian. Del f by del y del f by del y del g by del z, del f g minus this one is for, that is del y z. This is here del f by del y into del g by del z minus del f by del z into del g by del y equals y minus y by, same way it is again the Jacobian del f g by, it is del zx equals z minus z divided by again the Jacobian del of g by del xy. So this is the equation of the space curve which is passing through two of the curves S1 of xyz equals 0 and S2 of gxyz equals 0. Okay. So we know what is Jacobian. Okay. This is the Jacobian of del f by, this is del of g by del yz. This is nothing but del f by del y into del g by del z minus del f by del z into del g by del y and so on. Okay. So this is the equation of this intersection. So we are going to that is equation of this tangent to this curve. Now we are going to an example. The direction cosines of the tangent to a point. The direction cosines. Find the direction cosines of the tangent to a point xyz to the conic ax square plus by square plus z square equals 1 and x plus y plus z equals 1. X plus y plus z equals. How? So here we know what is f of x y z equals 0. So it is f of x y z equals, it is ax square plus by square plus z square minus 1. So it is 0. Similarly, g of x y z equals g of x y z equals, it is x plus y plus z minus 1 equals 0. Okay. So f of x y z and g of x y z, this is given. Now find out the direction ratios. These are the direction ratios and find the direction cosines. So these are the direction cosines. So what are the direction cosines? So the del of by, now consider this one, del of g by del yz. So it is del of g by del yz. Del of g by del yz. That is it is del of by del y into del g by del z minus del of by del z into del g by del y. So which equals, what is del f by del y? This is f, that is 2by into del g by del z, that is 1, and del f by del z is 2zz, so it is minus 2cz, and del g by del y is again 1. So it is 2 into by minus zz, 2 into by minus zz. Similarly, del of g by del zx, that is del f by del z. What is del f by del z? This is f, del f by del z is 2zz into del g by del x, that is 1, minus del f by del x, del f by del x, 2ax, so it is 2 into zz minus ax, and del g by del z is again 1. Also, what is del of g by del xy? Del f by del x. Del f by del x is 2ax. Del g by del y is again 1. Minus del f by del y. That is 2by. And del g by del y is, del g by del x is again 1. So the direction cosines are simply they are by minus zz, cz minus ax, and ax minus by. So these are the direction cosines of the tangent to the point xyz to the conic ax square plus by square plus z square plus equals 1 and x plus y plus z equals 1. That is follows from this argument. Okay.